Here we're asked how much time will be needed for $100,000 to grow to $118,146.18 if deposited at 6% compounded quarterly. For calculating, use the formula A is equal to P times 1 plus R over K raised to the K times T. And so we've used this formula. We learned about it and used it in our notes. And so we know that K is the ending value. In this case, they tell us we want it to grow to $118,146.18. So that's our A, 118,146.18. We know that P is the principal, the beginning amount, and we deposited 100,000 for it to grow. And so the 100,000 is the beginning amount, the P. And then parentheses, 1 plus, we know that R is the rate. They tell us the rate is 6%. And so changing that to a decimal, we get 0.06 for our rate for R over K. And we know that K is how it's compounded, how many times per year. And this one is compounded quarterly, which is 4 times per year. So K is 4. Notice here in our exponent, we have K again, still 4, doesn't change. And T is the time, and we're asked how much time, how long. So we're looking for T. So we're going to leave it as our variable T. And so now notice that we have an exponential equation to solve because the variable is in the exponent. And so we need to isolate our exponential equation first. Notice it's 100,000 times that exponential. And so we can undo that multiplication by dividing. So we're going to divide both sides by the 100,000. And so over here on the left, we're going to end up with 1.1814618. Notice it says over here in my math lab, do not round until the final answer. So I'm going to use all of those decimal places. I'm not going to round. And then over on the right, when we divide, our hundreds give us 1, they cancel, they go away, and we're left with the exponential, the 1 plus 0.06 over 4 raised to the 4 times t. Well, notice we can simplify inside the parentheses. That's all just numbers. It's addition and division. We know what 1 plus 0.06 divided by 4 is. We can put that in the calculator and figure it out if we don't know. And so on the left, we still have 1.1814618. And then 1 plus 0.06 divided by 4 is 1.015. And then we still have that raised to the 4t. So now we've simplified and we've got an exponential where it's a base raised to a power is equal to a number. And we solve an exponential by rewriting it as a log. So when we rewrite it as a log, it's going to be log. And remember, the base is going to stay the same. So because the base of my exponential is 1.015, that becomes the base of my log, 1.015. And then my input and my output switch. So notice here, 4t is the input. That's going to become the output. And then the output, 1.1814618, is going to become the input. So that's what's going to become what I'm taking the log of, the 1.1814618. And then the 4t that was the input for the exponential is going to become the output for the log. Now on the left, we have the log where the base is a number and what we're taking the log of is a number. So we can just put that in our calculator. Remember, some calculators will do bases other than 10 and E, and so you can enter it just the way it is. Other calculators, you're going to have to use the change of base formula. And so when using the change of base formula, remember you enter that in your calculator as the log of what you're taking the log of over the log of 1.015. And so that would switch it to base 10. Or you could switch it to base E and do ln, the natural log of 1.1814618 over the natural log, ln of 1.015. Either way, when you do, you end up with you end up with 11.2 is equal to 4t. Now, I didn't write the entire decimal, but I do still have the entire decimal in my calculator. So without rounding yet, I'm just going to hit divided by 4 in the calculator to get the t by itself. We're going to divide both sides by 4. And when we do, now we can round it. It wants us to round to the nearest tenth. So that's to 1 decimal place. And so when we round, we end up with 2.8 years. And so 2.8 years is how long it takes for this 100,000 to grow to $118,146.18.